In this video, we are going to look at solving absolute value equations. But before we can get into solving absolute value equations, we need to make sure we understand what an absolute value is. The absolute value of a number is the distance that number is from 0. So for example, if I have a 6, 6 is 6 units from 0, so the absolute value of 6 would be 6. However, negative 6 is also 6 units from 0, so the absolute value of negative 6 is also 6. So instead of concerning about the value and the orientation of the number, we're only worried about the absolute value of the number, and we're not concerned about its orientation as positive or negative. The way the symbol we use to say that we want to take the absolute value of a number is 2 vertical lines on either side of the number. So if I write this, that's the absolute value of 6, and that would equal 6. And the same thing if I have 2 vertical bars around a negative 6. That says that it's equal to 6, because we are only concerned about its distance from 0 and not whether or not it's positive or negative. So with that, let's look at some examples to see what it's like to solve absolute value equations. Alright, we'll start with a real straightforward example. We'll do the absolute value of x equal to 3. And before we blaze into figuring out how to solve this, let's take a moment to remember what it means to solve an equation. So when we're solving an equation, what we're looking for is what number or numbers I can substitute in for the variable to create a true statement. This equation is simple enough that we can really get it just by thinking about what would need to go into the x to create a true statement. Well, I could put a 3 in for the x because the absolute value of 3 is 3. But I could also put a negative 3 in for x because the absolute value of negative 3 is 3. So the solution to this equation is 3 or negative 3. And we're going to write that using set notation. So what that looks like is negative 3 comma 3 with these curly braces around it. And this is called set notation. So set notation is used to indicate distinct numbers. So negative 3 is a solution, 3 is a solution. This is different than interval notation. Interval notation is telling us a range of numbers with a starting value and an ending value. We use parentheses and square brackets for interval notation, but for set notation we always use these curly braces. Alright, let's look at a more complicated example now that we kind of have the idea of what it's going to mean when we solve an absolute value equation. Alright, let's do the absolute value of the expression 2x plus 3 equal to 5. Now this one's different because we have a more complicated expression inside of the absolute value bars instead of just one variable of x. Now one of the things I always like to encourage people when they're looking at expressions is to think of it as a number. Absolute values bars group things kind of like parentheses do. And so 2x plus 3 is a number. If we knew what x was, we could grind it down to that number. But without knowing what x is, we can still know that it's a number. It's just expressed abstractly. So this is saying whatever that number is, for it to make the equation true, it needs to be 5 units from 0. So that's saying that 2x plus 3 needs to equal 5, or 2x plus 3 needs to equal a negative 5. Now it's a subtle thing, but it's an important thing to understand that I am not changing this 5 into a positive 5 and a negative 5. That's not what's happening here. I'm saying that for this to be a true statement, what's inside the absolute value has to be a positive 5 or it has to be a negative 5. That's what I'm saying. Now that we have that set up, we can solve each one of these separate equations to figure out what x needs to be to make this true. I'll start solving the first equation by subtracting 3 from both sides. This gives me 2x equal to 2. And then I can finish isolating x by dividing both sides by 2. And so I get that x equal to 1. And then I'll just solve down this other equation. I start by subtracting 3 from both sides. And that gives that 2x equals a negative 8. And then I can divide both sides by 2. And that gives that x equals a negative 4. So again, these are the values that I could plug into my x in order to produce a true statement. If I plug the 1 in, I'm going to get the absolute value of 5 equals 5. If I plug the negative 4 in, I will get the absolute value of negative 5 equals 5. Both are true. And then I need to finish up by writing them in set notation. So I get negative 4, a comma, and a 1 inside of my curly brackets, braces, thingy-majiggers. Alright, let's do one more example that's slightly more complicated, and then I'll give you a chance to try some of these on your own. Alright, we have negative 2 times the absolute value of x plus 4, and then minus 5 equal to a negative 7. So what makes this one more complicated is there's now stuff outside the absolute value on the same side. And so I can't use my logic anymore that we were using before. I can't say, okay, I want to figure out what makes this negative 7 units from 0. That doesn't make sense because on the left it's not just that. It's something that's a distance from 0 that I don't know, times a negative 2 minus 5, and then that equals a negative 7. So it's too complicated to kind of puzzle out what that needs to be. So what we need to do to simplify it is we first need to isolate the absolute value so that it's the only thing on one side of the equation, in this case on the left side of the equation. Alright, so we need to isolate the absolute value by itself on the left side of the equation. In other words, get it by itself. So we need to get rid of the negative 2 and the minus 5. And we're going to do this in the exact same order. If I had negative 2x minus 5 equal to a negative 7, I would get x by itself by adding 5 to both sides and then dividing by negative 2. So we're going to do that same process, but there's an absolute value there. So I start by adding 5 to both sides. That gives me negative 2 times the absolute value of x plus 4 equal to a negative 2. And then I can divide both sides by the negative 2. And that gives me the absolute value of x plus 4 equal to 1. Now the absolute value is by itself on one side of the equation equal to a number. That means we can now consider that logic that we were looking at before. That absolute value, whatever's inside those absolute value bars, needs to be a distance of 1 from 0. So we get that the x plus 4 has to equal 1, or the x plus 4 has to equal a negative 1. So now to solve that, we just need to subtract 4 from both sides for both of these equations. So for the first equation, that's going to give me x equal to negative 3. And for the second equation, that will give me x equal to a negative 5. Alright, so all that's left to do is write that in set builder notation. And remember, you can always take your values and substitute them into the original equation to see if they will produce a true statement, and that is a way to check your answer. Alright, our set notation is negative 5, negative 3 with curly brackets around it, comma in the middle. And that one is done. So go ahead and give some of these a try on your own and see how you fare.